2024 A-Level Combined Mathematics Paper 2 Part A question number 6. This question has to do with vectors and the dot product. The question says, let u vector and v vector be two unit vectors such that u vector dot v vector is equal to half. Also, let a vector be equal to alpha u plus v and b vector be equal to u plus beta v, where alpha and beta are both elements of the real numbers. Now given this, the question says, if the vectors a vector and b vector are perpendicular and a vector plus b vector is parallel to u vector, find the values of the two constants alpha and beta. Now to start off with this question, we are going to use the first fact that states that a vector and b vector are perpendicular, and we are going to use the values of a vector and b vector in order to find an equation in terms of alpha and beta that we can then later use in order to find the actual values of alpha and beta. So for this first part, all we need to know is that if you have two vectors that are perpendicular to each other, let's say a vector and b vector, where the angle between them is 90 degrees, then a vector dot b vector must be equal to 0. Now using this in this particular situation, we can see since the a vector and b vector in our question are perpendicular, their dot product is going to be equal to 0. So we can say since a vector comma b vector are perpendicular, we can say therefore their dot product a vector dot b vector must be equal to 0. Now from this, in order to find an equation in terms of alpha and beta, we are going to have to substitute the values of a vector and b vector in terms of alpha, beta, u vector and v vector. So doing so, we can see instead of a vector I have this, and if I substitute I have alpha u vector plus v vector dot, and for b vector similarly I have u vector plus beta v vector, so I have dot u vector plus beta v vector equals 0. So this is the equation I get by substituting a vector and b vector. Now at this point, we can simplify this down by using the fact that the dot product simplifies in the exact same way that multiplication does. So from this we can see we have two terms here and two terms here, and when we take the dot product, we have the same exact multiplication that we have with normal multiplication. So due to that, we get four terms, one term from this term and this term, one from alpha u and beta v, one from v and u, and one from v and beta v. So therefore we get the first term alpha u vector dot u vector, alpha u vector dot u vector, plus the second term which is going to be alpha u vector dot beta v vector, alpha u vector dot beta v vector, plus and the second terms which are v vector dot u vector, v vector dot u vector, plus and finally v vector dot beta v vector, v vector dot beta v vector, and after expanding on the right hand side we still have 0. Now from this, in order to find an actual equation, we need to run some substitutions. We need to do substitutions for u vector dot u vector, v vector dot v vector, and also v vector dot u vector, and over here u vector dot v vector. Now for this, we need to first use the fact that u vector and v vector are both unit vectors. Now due to this, as we know, for any vector a vector dot itself is going to be equal to the modulus of a vector squared. Now applying this to unit vectors are vectors that have modulus of 1, and therefore inside of here we're going to have 1, and 1 squared is equal to 1, and therefore any unit vector dot itself is going to be equal to 1. So according to this, over here we have u vector dot u vector which is going to be equal to 1, and over here we have v vector dot v vector which is also going to be equal to 1. So if we apply that, we can see here we have alpha times u vector dot u vector which is alpha times 1, and therefore this term is simply alpha. So here we have alpha. Now similarly, from this term we have v vector dot beta v vector, and if we take the beta to the front, we have beta times v vector dot v vector which is equal to 1, and therefore we have beta times 1 which is beta, which I'm going to take the front as plus beta. Now similarly, we need to simplify this term and this term. However, for these two, we introduce the fact that u vector dot v vector is equal to half. Now considering this term right here, we can see we have v vector dot u vector. Now as we know, the dot product is commutative, and therefore u vector dot v vector is the same thing as v vector dot u vector. So according to that, if u vector dot v vector is equal to half, then this term right here must also be equal to half. So we can take it to the front and write it as plus a half. And then finally, we have this last term, which is alpha u dot beta v. Now if you rearrange, we can take the alpha and the beta to the front and have alpha times beta, but then we are going to have u vector dot v vector, which is again equal to half. So alpha times beta times a half, which is going to be half alpha beta. And that whole thing is equal to 0. Now at this point, I'm going to call this equation number 1 and move on to my second fact regarding vectors a and b in order to find another equation of alpha and beta that I can then use in order to find the values of alpha and beta. So at this point, we are done with a vector and b vector being perpendicular. Now let's move on to our second fact, which states that a vector plus b vector is parallel to u vector. Now as we know, whenever you have two vectors that are parallel to each other like so, let's say we have this vector and this vector, where this is, let's say, p vector and this is q vector, we must have p vector being equal to lambda times q vector, where lambda is a scalar that is an element of the real numbers. Given that p vector and q vector are parallel, this must be the case. Now according to this, if we apply the situation for a vector, b vector and u vector, we can see a vector plus b vector is parallel to u vector, and therefore we can say, since a vector plus b vector is parallel to u vector, a vector plus b vector must be equal to some scalar multiple lambda times u vector, where lambda is a constant which is an element of the real numbers. Now, using this, what we can do is use the fact that if you have any two vectors, let's say u vector and v vector, that are not parallel to each other, then p times u vector plus q times v vector being equal to the null vector means that p and q are both equal to 0. Now we will see exactly how we can use that fact in this equation by substituting the values of a and b, and we will see that we can get an equation in this form that we can then use in order to find that p and q are both equal to 0, where p and q are two constants in this equation, where p is a constant in front of u vector and q is a constant in front of v vector. So if we just try to do that, if we try to substitute a and b and rearrange to get that form, we can see for a we get alpha u plus v, and for b we get u plus beta v, and then that is equal to lambda times u. Now here, if I subtract lambda u vector from both sides, on the left hand side I'm going to get alpha u vector plus v vector plus u vector plus beta v vector minus lambda u vector, but on the other side I'm going to have lambda u vector minus lambda u vector, which is going to be 0 over the null vector. So therefore, on the left hand side I have all of this, but on the right hand side I have the null vector. Now at this point I can see I have two types of terms on the left hand side. I have terms that have a u vector in them, and I also have terms that have a v vector in them. There are three terms with u vector in them and two terms with v vector in them. Now if I factorize these out, we can see for u vector terms I have alpha, 1 and negative lambda as coefficients. So therefore if I factorize them, I have alpha plus 1 minus lambda times u vector, and similarly for v vector I have 1 and beta, so I have 1 plus beta, beta plus 1 times v vector equal the null vector. Now at this point we can see we have the form that I described, the form of p times u vector plus q times v vector being equal to the null vector. Now given this, as I said, if u vector and v vector are not parallel to each other, then p and q must both be equal to 0. Now for this, of course, we need to prove that q vector and v vector are not parallel. Now as we know, considering the dot product, if ever you have a vector dot b vector, it is equal to the magnitude of a vector times the magnitude of b vector times the cosine of the angle theta, where theta is the angle between the vectors a vector and b vector. Now considering this, for any two vectors, theta is going to have some value. As we make these two vectors close and closer together, the value of theta becomes smaller, and in the limit, when the two vectors are parallel to each other, the angle theta is going to approach 0. Due to this, when we have two parallel vectors, let's say a vector and b vector, the angle theta is 0, and due to that, the cosine of theta is going to be equal to 1, as cosine of 0 is equal to 1. So due to this term is going to be equal to 1, and therefore we can cancel it out, leaving us with a vector dot b vector equal modulus of a vector times modulus of b vector. Basically, the sizes of the two vectors multiplied together is equal to dot product. Now, this is the case when the two vectors are parallel, and only when the two vectors are parallel. Due to this, if you have two vectors where a dot b is not equal to the product of their two magnitudes, then those two vectors are not parallel. So according to that, all we need to do is to show that u vector dot v vector is not equal to modulus of u vector times modulus of v vector, which is actually quite easy. We already know the value of u vector dot v vector is equal to half. That part's a half. But on the other side, we have modulus of u vector times modulus of v vector, and both of these are equal to 1, as u vector and v vector are both unit vectors. So therefore, here we have 1 and here we have 1. Multiplying, we get 1. On the left hand side, we have a half. Right hand side, we have 1. And they are clearly not equal. So due to that, we can apply the theorem and directly say that the two coefficients of u vector and v vector here must be equal to 0. So therefore, we can say alpha plus 1 minus lambda is equal to 0 and beta plus 1 is equal to 0. But for this, we need the justification that u vector and v vector are not parallel to each other. So for this, what we're going to do is to say because, and we're basically going to write out everything that we already just wrote in my little discussion over here. So I'm going to say this is true because u vector and v vector are not parallel. And as proof that they're not parallel, we are going to show that u vector dot v vector is equal to half as given, which is not equal to the product of the magnitudes u vector times v vector's magnitude, which is itself equal to 1 times 1, which is 1. We can see 1 and a half are not equal to each other, and therefore, since u dot v is not equal to u vector times v vector sizes, we can say that u and v are not parallel, and therefore, considering this equation with the form of p times u vector plus q times v vector being equivalent to null vector, p must be equal to 0 and q must also be equal to 0. Now using that, we can see we have two equations, one of which is useless, but the other one of which is actually very useful because it directly gives the value of beta. This one is not useful, but this one we can see, if we take the one to the other side, directly gives us that beta is equal to negative 1. So with this equation, we have already found the exact value of beta. Beta is equal to negative 1. So for this, in order to find the value of alpha, all we need to do is to take the value of beta equals negative 1 and substitute it back into equation number 1. So doing so, I can see from equation number 1, if I substitute beta equals negative 1, I have alpha plus beta, which is minus 1, plus a half, and then you have plus a half times alpha times beta, which is going to be equal to half times alpha times negative 1, which is going to be negative a half alpha. So we have minus 1 half alpha. On the right hand side, we have 0. And simplifying this down, we can see if we keep the alpha on the left and take everything else to the right side, we have alpha minus a half alpha, which is going to be equal to alpha divided by 2 equals, and if you take these to the other side, we have plus 1 and minus a half, and plus 1 minus a half is going to be equal to plus half, and therefore we have alpha over 2 equal 1 over 2. And from this we can see, when we multiply both sides by 2, we have alpha equals 1. So from this we found the two values of alpha and beta. Alpha equals 1 and beta equals negative 1. And with that, we are actually done with this question. So now finally, let's go up and discuss how the marks are awarded for this part of the question. So at the top, for writing that if a vector and b vector are perpendicular, their dot product a vector dot b vector must be equal to 0. Writing that alone gets you 5 marks. The reason for that is, of course, because they want to find that you know that if you have two vectors perpendicular to each other, then their dot product must be equal to 0. Knowing that and showing that you know that knowledge gives you 5 marks. Now after that, when you take the values of a vector and b vector, substitute them in like this, simplify, and use u vector dot u vector, v vector dot v vector, and u vector dot v vector to get this equation right here. Getting this equation gets you another 5 marks. Now after that, similar to the first part of the question, when you say that since a vector plus b vector is parallel to u vector, a vector plus b vector must be a scalar multiple of u vector, writing this equation out gets you another 5 marks. Now after that, when you substitute the values of a vector and b vector, get to this point where you have one coefficient times u vector plus one other coefficient times v vector, where these two vectors u vector and v vector are not parallel to each other. You get 5 marks for getting to this point, and then using this logic, when you say that this is equal to 0 and this is equal to 0, to get beta equals -1, substitute that correctly and get the correct value of alpha as well. For finding the two values of alpha and beta by using this logic right here, you get a final 5 marks. And with that, we are done with this question. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching, and goodbye.